Continuing with our discussion on functions, we will talk about graphing functions. I know in Algebra 1 we graphed. We'll show you two different ways right now. Later in the week we'll get into the more more precise, the quicker of the graphing methods. But this is a good foundation and a good place to start. I want us to graph. Ooh, we don't want that. Y is equal to x plus 1. So what we'll have here is we're going to create a table of values. We're going to have x, and then we're going to have y. So when I put in, let's just start at -2. We'll go -2, -1, 0, 1, and 2. When I have -2 and I substitute it in for x, that gives me -2 plus 1, that's -1. When I have -1 and I substitute it in for x right here, plus 1, I get 0. When I have 0 in for x, 0 plus 1 is 1. When I substitute 1 in for x, I get 2. And when I substitute 2 in, I get 3. Now I'd come over here to my graph, and I would plot those points. -2, I go over 1, 2, and then down 1. -1, 0, I go left 1, and stay on the x-axis. And then 0, 1, I just go from the origin, up 1. 1, 2, I go to the right 1, and then up 1, 2. And then 2, 3, I go 1, 2, and then up 1, 2, 3. So right there I have 5 points. Now all I have to do is connect these with a straight line. Hopefully this gets them all there, yep. Okay, and that's how that graph would look. Okay, a couple of things to know here with this is that our y-intercept, this is the y-intercept. 0, 1. Okay, 1 is the y-intercept. Our slope, I know something you've heard about, is 1 over 1. So from one point we rise 1 and run 1. Rise 1, run 1. Rise 1, run 1. Okay, so those are a couple of different things that we'll use to graph other ones. But for any type of graph, from now until calculus, you can do an input-output table and plot your points, connect the dots, and graph your line or curve, just like we did here with this table of values. We are going to graph one more here. I'd like us to graph, let's think y is equal to 2/3 x plus 2. We'll create, and here how we're going to graph this, we're going to graph it by saying our slope m is 2/3. So that's a rise of 2 and a run of 3. Okay? Our y-intercept is 2. Just to remind you, m is slope. Okay, our y-intercept is 2, so what that tells us is the point 0, 2 is on our graph. So that's a great place to start, is with 0, 2. Come up 0, 2. And then we always start from that point, that y-intercept, and we use our slope. We rise 2, 1, 2, and then we run 3. 1, 2, 3. So those are our 2 points. All we have to do is connect the dots. If you notice, we can go 1, 2, and then 1, 2, 3 again. 1, 2, 1, 2, 3. We can keep doing that. We could also work back. We could actually go down 2 and then left 1, 2, 3. That's on there because 1, 2. then down 1, 2, 1, 2, 3, down 1, 2, 1, 2, 3, 1, 2, 3. And we get that point all the way out there. Because if we think about it, if we start back here, we go up 1, 2, right, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. We see our rise 2 and our run 3 the whole way through, getting those points. All we'd have to do here is connect the dots with a straight line. Again, this is in slope-intercept form. We could have done a table of values here as well, but I wanted to show you this as well. We'll see both of those as we go forward. The last thing we'll talk about here today is function notation. I'm sure you've seen it before. Sometimes it's confusing at first because it looks different, and that's all right. I think once we do a few more examples here, you see these, it'll hopefully make a little more sense. Now this symbol, f of x, is read as the value of f at x. Or you could read it as f of x, f at x. So if we consider f of 2x, f of x is equal to 2x plus 6. We're going to evaluate this function of f at x equals 2. So what that means is we have f of 2. We're evaluating f at x equals 2. So what that means is I substitute 2 everywhere I see x. And then I add 6. From here we just simplify the right side. We do nothing over here. Nothing with the f of 2. 2 times 2 is 4 plus 6. Simplify the 4 plus 6, we get 10. So what that says is when x is 2, our output, our function value is 10. If you want to think of it as in terms that you're really comfortable with, when x is 2, y is 10. Let's do one more with that one. We're going to do f of x is equal to 2x plus 6. And we're going to find f of 7. So again, that means everywhere I see x in my function, 2x plus 6, I substitute 7. So I have 2 times 7 plus 6. And again, we do nothing with the f of 7. We do nothing with that. 2 times 7 is 14. Then we add 6. 14 plus 6 is 20. So when x is 7, our function value, or our y value, is 20. Our input is 7. Our output is 20. Going to show us one more. We're going to use that other function up there. This time we have f of x equals negative x squared minus 3x plus 5. This time we're going to find f of negative 4. So now everywhere we see x, we substitute negative 4. So right now I have the opposite of negative 4 squared minus 3 times negative 4 plus 5. So everywhere I see x, I substitute in negative 4. Now we simplify. Negative 4 squared, that will give me the opposite of 16. Because negative 4 squared is positive 16, but I still have the negative out front. Negative 3 times negative 4 is plus 12 plus 5. So this is now negative 16 plus 12 plus 5. When I simplify that, I get positive 1. So in this function here, when x is negative 4, our output value is positive 1.